I'm presenting impact tester, falling weight impact tester for determination of the puncture impact behavior of rigid plastics according to ISO 6603-1. This model is specifically designed with the maximum height of 2 meters with two types of carriers. Here you have two types of carrier for small weights and higher weights, and also set of weights, set of masses, big diameters, mid-size and small weights. Here two types of the impact striking head, 10 millimeter and 20 millimeter, and you can set any appropriate weight for your samples according to different mass plan as a stable. You can get different weights of the striking head with the different combinations of the weight, carrier and the head, and you will have different masses like 500 gram, 800 gram, 100, 1000 gram and so on. This is the table that will be with the machine. You can easily set the proper weight as your proper for your samples. Okay, here to catch the weight of requested weight, you always need to use 4 pieces of the bigger weights, here, and 3 pieces of a smaller weight, or in any situation you need to use 7 pieces of masses, the smaller weights or mid-size weights or bigger one, but be noted that the bigger one need to be in the upper position, not to have the risk of striking these fingers. That is for second impact restrictors, preventors, and it's proper to use the bigger masses in upper position of the holder of the screw, and it's easy to set the requested weight using the combination table. Now I'm using 20 millimeter hemispherical head according to the standard. After this you can release the fingers here, bring it down. Before, just put the sample piece here. You also have a pneumatic gripper for the sample piece. Here you have a valve. And just open. Here you have sample piece. This is for demonstration. According to the standard, you have the proper size of the sample piece. I'm just putting it here just for the demonstration. You put it like this, then you can grip it. For having proper distance from the sample piece to the striking head, you need to take a look at this distance, the distance between the lower edge of the striker and also the finger for prevento, second impact prevento finger. The proper distance is around 2 or 3 centimeters for the proper application of the second impact prevento. Here these pneumatic cylinders is for second impact prevention according to the norm. For the proper use of these preventos, you need to set this distance to about 2 or 3 centimeters. For this you can easily use these 2 keys, up and down, moving of the base, moving the sample table. I'm just bringing it down. The sample, the striker is released here. It's on the sample piece. I'm just bringing it down. Here. It's okay. Here will be 0 position for me. I need to set the 0 position. I'm just If I open here, here you see the here you have the gripper for the striker, and using these two up and down keys on the touch screen, you can move it upward and downward. I'm bringing it down. Also, you can using this volume key, you can set the speed of movement. Yeah, reduce or increase the speed of movement like this. First of all, I need to set the 0 position for the gripper. I'm bringing it down. This proximity switch to touch to see this barrier. Slowly bring it down. Yeah, here will be the 0 position for our weight. I'm setting here the 0 position by pressing the reset button. Then I want to use the impact distance of 100 centimeter. For this sample piece, let me set the distance to 50 centimeter. And for this specific sample, after this the gripper for the striker, the proximity switch on that touches this barrier on the striker, I set the reset button and also set the height of impact to 50 centimeter. Then we'll move the gripper upward to have the setting to the 50 centimeter. I'm reducing the speed to have the fine adjustment of the height. Yeah. Now it's 50 centimeter. Then we have cyclic impact setting, multi-impact test. This is if we want to test according to this ISO norm. This is multi-impact. This is only single test. Sorry, this is single test. I mean, only one time of the striker will hit the sample piece, and that will be enough. And then we will go to the next level of the height. In some cases, for example, in staircase testing of the impact test of the UPVC pipes, you will need to have a multi-impact testing. For multi-impact testing, you have impact set point here, that is the number of automatic impact on the sample piece. And as I said here, as per this ISO norm, we will have only single test. Yeah. Okay. Now we are ready to do the test. I'm just clicking on single test. That's all. Here on the setting page, we have setting for these times. I mean, as you saw, after the striker go into the gripper, we will have a time, definite time for the release of the striker, and the time is here. If we are on single test, this is dart release delay time, that is in terms of 100 millisecond, and if I set it to 50, it means that 5,000 millisecond, that is 5 seconds after the striker go into the gripper. After 5 seconds will be released automatically. Also, the second impact prevent time here on single test is a time that after the first impact is done here on the sample piece. After the first impact done on the sample piece, the striker will be rebounced from the sample piece. And for the second impact prevention, these pneumatic cylinders will start working, as well as the other cylinder that is in the back side. And for definite time, that is only 2 seconds, or you can set it to 1 second. I mean, if you set it to 100, means that 1000 millisecond, that is 1 second. 1 second it will be coming up and then going to the 0 position again slowly. and that is for the prevention of the second impact for the bounces of the striker from the sample piece. Here, the testing is easy. If you want to do according to this norm, we will have 10 pieces of sample piece for defining the starting weight of the testing. I mean, you will have 10 samples only for definition of the starting position. The starting mass of the striker will be defined using 10 sample piece. We will set this weight in such a way that 50% of those samples for defining starting mass will be failed, and that will be the starting mass for the start of the process of testing of 20 pieces. Here, after we define the starting mass, for this case, as per the standard, this is a sample of the standard, the starting mass is 1.2 kilogram. Then we will hit the sample piece, and then it will be failed. Here, this marking is for failure, and the O mark is no failure. After the sample is failed, then we will go to the next step, that is with the definite step lower than the starting mass. Then we will reduce the mass, reduce the height here. Here on this setup, we will reduce the height of impact. Then after the sample is not failed, then we will increase the weight, we will increase the weight, we will increase the weight for the sample to be failed. After the failure is done, then we will reduce the weight, and we will do the process up to 20 pieces of the samples. And we will have the data like this, this graph. This is for yes, this is height of fall. We will have minimum height of fall, and then these information will be gathered from this from here. This table information will be gathered. Yeah, you see that we have a height of fall of 1 meter. Then on 1 meter, number of non-failures is 3. Number of failures is 0. For the second step, that is 1.2 meter. Non-failures is 6. We will count the non-failures on this row, and then the failures also will be counted here. That is 3, and we will do this process to calculate the total value of the non-failures and failures. Then according to which one is the lower than the other, we will choose that Ni, that will be the lower value here. On this case, summation, the sum value of the failures is 9, and here we have 11. And then we will choose the failure column as Ni. The Zi is calculated according to the formula. That is H for each row. And here on this table we also have Z values. Zi values is calculated according to this formula. That is the height for each row minus minimum height, that is on this case is 1. And delta H is the increments of the height, that is on this case is 0.2 meter. In every step we increase or reduce the height by 20 centimeter, that is 0.2 meter. The Zi will be calculated, then Ni multiplied by Zi will be calculated here. The summation is A, and N is the summation of the Ni. Then we have everything for the formula here. H50 will be calculated according to this formula. HA is the minimum, the delta H is the height increment, N is the summation of the Ni. According to the situation will be chosen which one is the Ni, if it is Nix or if it is NIO. Here And also we have here a point that is plus minus. According to which one is chosen for NI, this formula will be with plus or minus sign. Yeah, here we have everything for the calculation. Okay, here in this case we can do the test. Starting with the I'm going to the table here. First of all, I'm setting the starting weight, that is 1 kg here. Then I'm defining the increment, that is 0.2. Then I calculate the weight plan, the height plan. I mean, the starting height is 1 meter here, and the other height values will be calculated according to this increment. I'm resetting here to have the table the row table to input the value. For demonstration, I'm choosing the values of the standard sample piece here that I showed. Yeah, I want to do this test setup according to the standard sample. The starting is 1.2. Yeah, here. I will start with the height of 1.2. On this sample piece, it will be fail, but I want to show you the setup. I will come here. We'll set the height to 120 centimeter. Then we'll go up to have the position on 120 millimeter, 120 centimeter for the starting height. Okay, we have the starting height. Then I'm coming back to the table. I will do the test on the sample using single test. Yeah, on this test I'm sure that it will be fail, but I will show how to do the procedure. Yeah, we have no failure here. I'm coming here to feel the table. We have 1.2 meter, and I'm just filling the table according to the norm. Here we have no failure, but I'm setting here as failure. If I click one time, will be fail. If I click 2 times, that is a circle, is no failure. And if I click one more time, you will have empty, and that is nothing. Here we have a failure 1 time. Then we will reduce 1 step in the height, that is 1 meter. Here I will come back here to reduce the height to 100 centimeter. Yeah. Then I'm coming back here to 1 meter. We have 1 meter. We will do the test, and it will it says no failure. I mean, click 2 times, that is no failure sign. Then you will fill the data here. No failure. Then next step is no failure, 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 no failure, 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 no failure, no failure, fail, no failure, fail, no failure, fail, no fail, fail, and here also fail, and no fail here, no fail, no fail. After finishing of the 20 samples, we will come here to see the calculation. We have the table here, as I showed you. After filling the data for the table, it will calculate the values according to the norm. No failures is in the first column, failures is on the right column. The sum of these no failures and failures is here. Because of the failure column summation is less than the no failure column, then automatically the values of the no failure, here we have 11, here we have 9. Then the failure column will be chosen for the NI value. ZI calculated according to the formula, and NI ZI multiply is here in this column. And the energy will be calculated here according to the test data. After the testing is done, you can have saving here of the data. Will be saved the data up to 2000 sample piece. Will include the time, date, sample size, wall thickness, sample information, customer, everything will be filled here. And anytime you put the flash disk here, we have USB connection, 2 USB connection. This one is for firmware update of the software of the screen, and also the second one is the USB for the flash disk, saving of the data as Microsoft Excel file to flash disk. And for the general parameters of the samples, you can come here, parameters, and fill the data here. You have two types of striker head, 10 millimeter or 20 millimeter. The second page. Also you have the two types of ring diameter. Ring diameter is here. That is a gripper for the sample piece. Also according to the norm, you can choose two test method if it is clamped or unclamped. You can put the sample piece here with no clamp, or you can put it here with clamp, but the test results will be different as the standard says. Yeah, you can easily change the clamp here. You have two types of clamp size for the sample according to standard. You can easily open these nuts here and open these screws and change the base and also the upper clamp for the sample piece. If you choose other sizes according to the standard. Here we have selection of the clamp or unclamp sample holder. Here we have a ring diameter of 40 millimeter or 100 millimeter. This model is 40 millimeter. The other one that is already installed is 100 millimeter. We also have type A and type B. You can select it here. These two pages is for the sample parameter setting. We also have access to test table here. Here we have setting page, setting of the height, and also nothing more. Yeah, everything is clear here. We also have fingers here. If you want to set this striker, to change the striker, you will bring it up. Bring fingers here, stopper fingers. Yeah, then you can loosen these screws, loosen these slides, brass slides, and you can release it from the position here between two columns, and then replace it. That's all. Nothing more, I think. Yeah, here also, here we have limit switches for the movement of the table. Whenever I'm coming down, for example, the lower switch will be activated, and this is the maximum position of the movement for the table. Here you can change, in case of need, you can change the position for these limit switches as well. Here you have screws. You can loosen those screws here for the holders of the switches and bring it down, or if the modification of this position is low, you can easily loosen this screw and change the angle of this finger. Yeah, just loosen this screw, then rotate the finger like this. Now it's in here. If you loosen this screw, then you will change the angle. Then the maximum travel of the plate will be changed according to the new setting of the finger for the limit switches. Everything is clear. Thank you for choosing thank you for choosing impact tester from AHP Plastic Machina. This one is specifically puncture impact test, non-instrumented puncture impact test according to ISO norm. Thank you.